Hi, welcome to the lecture session on tutorial session 1. Today we are going to discuss some of the problems. Uh, First, let us discuss one problem in the Cauchy's form, which we have already taught. X cube d cube y by dx cube plus 3x square d square y by dx square plus x into dy by dx plus 8y is 65 into cos of log x. Put t is equals to log x or x is equals to e power t. Then we get x into y dash is a dy, x square y double dash will be d into d minus 1 of y, x cube into y triple dash will become d minus 1 d minus 2 of y, where d is d by dt. So on this substitution, the given equation reduces to d minus 1 d minus 2 plus 3d minus 1 plus d plus 8 of y is equals to 65 cos t. That on simplification we get d cube minus 3d square plus 2d plus 3d square minus 3d plus d plus 8 of y is 65 cos t. Now we can observe d square terms gets cancelled, that is minus 3d square and plus 3d square, and also the d term gets cancelled, that is plus 2d and minus 2d. Remaining is d cube plus 8 of y is 65. So when we are taking the auxiliary equation of this, we get m cube plus 8 is 0, or it is exactly in the form of a cube plus b cube, which can be written as a plus b into a squared minus ab plus b squared. That is m plus 2 into m squared minus 2m plus 4 is 0. When we equate the first factor to 0, we get it as minus 2. And when we equate the second factor to 0, which can be solved by a formula method because we are having a imaginary roots. So we get 2 plus or minus root of, that is b plus or minus b plus or minus square root of b squared minus 4ac by 2a. In that form, if you apply, we are getting 2 plus or minus 2 square, that is 4 minus 4ac. So 4 into a is 1, c is 4. We get 16. And that is minus 12. And we can take 4 outside, that will become 2. And 2 will be cancelled in the numerator and then the denominator. So we are getting 1 plus or minus I root 3. This is the roots we are having, that is 3 roots we are having. One is minus 2, another 2 is a complex conjugate roots. So it is a mix of both real as well as complex conjugate. So we have to write the solution in terms of t because a capital D is d by dt. Therefore, c1 into e power minus 2t plus e power t into c2 cos of root 3 of t plus c3 sin of root 3 of t. And yp part. When it comes to yp part, we have 65 cos t divided by d cube plus 8. And whenever we have a cos or a sine term in the right hand side as a phi of x, we need to replace the d square with minus 1 square. That is minus 1. It is not minus 1 the whole square, it is minus 1 square. So we are getting minus 1 and 8 minus 1, which will be 8 minus 1 will not get it, and 8 with minus d because d square is replaced with minus 1 and d will be as it is. So we are getting minus d plus 8. Still we are having 8 minus d in the denominator. In order to eliminate the d and 8, what we need to do is we are multiplying its conjugate. The conjugate of this is d plus 8. So let us divide and multiply with d plus 8. So when we do that, 65 times of 8 plus d of cos t divided by a plus b, a minus b form, if we apply, it will be 64 minus d square. And in the numerator, when we expand, 65 times of 8 cos t minus d cos t, where d cos t can be taken as a derivative of cos t, which becomes minus of sin t. And in the denominator, for both the numerator we are having sin t as well as cos t, and the coefficient of t is 1. Therefore, d square will be replaced with the minus 1 square. And it is not minus 1 the whole square, that is 1 square attached with a minus 1. Therefore, we get 64 minus of minus 1, that is 65. And here 65 in the numerator and denominator gets cancelled. We get the answer for yp as 8 cos t minus sin t. So on adding the yc and the yp part, we get c1 divided by x square, and also we are replacing it with the substitution. So we get x times of c2 cos root 3 log x plus c3 sin root 3 log x, and plus yp part, that is 8 cos log x minus sin log x, because cos t is replaced with the log x. So this is the answer we are getting it. Let's go for the Legendre type. One we have solved in the Cauchy's. Now let's go for the Legendre type. That is 2x plus 1 the whole square into y double dash minus 2 into 2x plus 1 into y dash minus 12 of y is 6x plus 5. And we need to replace this for the Legendre as t equals to log of 2x plus 1 and e power t as 2x plus 1. So the given equation reduces to 2x plus 1 of y dash is 2 dy, 2x plus 1 whole square into y double dash is 2 square d minus 1 of y, where d is d by dt. Therefore, we on substitution and simplification, actually we get 4 times as a common, which can be taken to the right hand side and then or divided out. Then on simplification we get d squared minus 2d minus 3 of y is 3 by 4 times of e power t plus half. Now consider the auxiliary equation, which gives m squared minus 2m minus 3, or m is 3 and minus 1. So our yc part is c1 e power 3t plus c2 e power minus t. Then yp part. Coming to the yp part, we get 3 by 4 times of e power t divided by t squared minus 2d minus 3 plus half times of, actually 1 is there, actually 1 by 2 is there. So 1 can be written as e power 0t. And when we replace d with the 0, we are getting only minus 3 in the second part. And in the first part, e power t, d square is 1 square, minus 2d is 2 into 1 minus 3. And this on simplification, we get it as 4, that's minus 4 or 16. And in the second part, it is minus 1 by 6. So y is given by c1 into 2x plus 1 the whole cube plus c2 divided by 2x plus 1 minus 3 into e power t is replaced with e 2x plus 1 divided by 16 minus 1 by 6 as it is. Thank you.